A group of office workers were questioned for a health magazine, and 2/5 were found to take regular exercise. So, regular exercise, 2/5, that is the probability. When questioned about their eating habits, 2/3 said they always eat breakfast. So eat breakfast, that is 2/3. We can just write this here. Probability of regular exercise, E, so that is 2/5. Probability of eating breakfast, B, that is 2/3. And of those who ate breakfast, this particular information means given. This means given. Of those who ate breakfast, that means given that the person had breakfast, the probability is 9/25 of doing regular exercise. This right here is a conditional probability. So probability of doing exercise when the given information is the person already had breakfast, that probability is 9/25. Watch out for that given information. Probability of having regular exercise when it is conditional given that he had breakfast is 9/25. That makes it a probability formula sum, where we use the set notations to do the sum. Find the probability that a randomly selected member of the group always eats breakfast and takes regular exercise. And means intersection. We have to find probability regular exercise, breakfast intersection exercise. For this we have to use the formula. So the formula is this conditional probability. Let me review it a little bit. When you do these type of sums, the probability formula that you need is, first of all, A union B. The formula is probability of A plus probability of B minus probability of A intersection B. The formula for A conditional B is the first one intersection the second one divided by the second probability. So these are the probability that we need. Since in the information we know probability of E conditional probability of B, we know the formula is probability of E intersection B divided by probability of B. Probability of E intersection B and B intersection E is the same thing. Probability of E conditional B is 9/25. Probability of E intersection B is what we have to find out, and the probability of B is 2/3, 2/3. Therefore 9/25 multiplied by 2/3 is probability of E intersection B. Therefore probability of E intersection B is equals to, if we multiply this would be 3 3s are 9, so this would be 6/25. Question B. Does not always eat breakfast, and that means prime, B prime, and does not take regular exercise. Does not eat breakfast is B prime, and means intersection. Does not take regular exercise is E prime. So that means probability of B prime intersection probability of E prime. That's what it means. In order to do this sum, let me write out probability of B prime intersection E prime. If you remember, when you have to do a prime intersection something, you don't need a formula, you need the Venn diagram, and the Venn diagram looks like this. this is B, this is E, so E prime intersection B prime in this outside region. Both of them prime intersection means you remove it. That means from the total probability, if you remove the probability of these two, which is B union E, then you can find this. This equals to 1 minus probability of B union E. This can be found using the formula that I just mentioned. So probability of the first set union the second set is add up the two probabilities, subtract the intersection. Remember what we just found. We just found the intersection. The union can now be easily found using this. We know probability of breakfast union exercise is equals to probability of breakfast plus probability of exercise minus probability of breakfast intersection exercise. Probability of breakfast is 2 by 3 plus probability of exercise is 2 by 5 minus probability of breakfast intersection exercise is 6 by 25. Remember, E intersection B and B intersection E is the same thing. 2 by 3 plus 2 by 5 minus 6 by 25 is 62 by 75. Therefore, let's get back to the original sum. Probability of B prime intersection E prime is 1 minus probability of B union E, which is 62 by 75. 1 minus that is 13 by 75. The final question, determine, giving your reason, whether or not always eating breakfast and taking regular exercise are statistically independent. In these types of probability formula sum, the final question is usually where you have to prove whether the probabilities are independent, and the rule is if the probabilities are independent, then the probability of A intersection B should be equal to probability of A times the probability of B. If they're equal, then they're independent. If they're not equal, they're not independent. Usually what happens, it is proved that they're not independent. So let's see what happens here. So probability of B intersection E, this intersection is 6 by 25, we already know. So probability of B multiplied by probability of E, so this is probability of B is 2 by 3 multiplied by probability of E is 2 by 5. If you multiply 2 to the 4 by 15. Now you see that this and this, they are not equal, so you write since probability of breakfast intersection exercise is not equal to, this is how you have to present it, probability of B into probability of E, the events are not independent.